to my channel. So today we are going to learn about the electronegativity, bond polarity and also dipole moment. But in this part 1, I'm focusing on the electronegativity. Right, so today we are going to discuss, or I will be explaining to you about the trends of electronegativity, or we write it down as EN. So what is electronegativity or EN? EN is actually the ability of an atom to attract the bonding electrons toward itself in a chemical bond. So what we have learned previously, we have learned about the electron affinity, right? Okay, so this electron affinity is actually a measurable, where for example we have a chlorine, okay, has the highest electron affinity. Okay, so here where for example here we have X, okay, or Cl, chlorine. Okay, this chlorine accept 1 electron. Okay, when this chlorine accept 1 electron, what happen? It will become chloride and anion. Okay, so why we call it as electron affinity as measurable? Because the energy change when 1 mole of electron is gained by 1 mole of gaseous atom. So we can measure the energy change, right? But okay, for the electronegativity, it is actually a relative. Okay, for example, fluorine is the highest with the electronegativity value 4.0. So this EN or electronegativity is actually a function of two properties of isolated atoms. First one, based on their ionization energy. So this is how strongly an atom holds onto its own electrons. Okay, and second one, based on the atom's electron affinity. This is how strongly the atom attracts other electrons. Okay, so in this slide, I have one example here. For example, here an element which has first one a large electron affinity means it is actually a negative charge element. Okay, or an negative charge ion. Okay, and second one a high ionization, so it always endothermic or positive for neutral atoms. So electron affinity related to the anions, while for the ionization energy, it is actually related to the positive or neutral atoms. Okay, so this element, okay, this element will attract electrons from other atoms and resist having electrons attracted away. So this atom can be considered or will have highly electronegativity or highly electronegative. So based on the electronegativity, we have Paulins scale. Okay, so the higher the value, the more electronegative the element. Okay, so atoms with high electronegativity or high EN values, okay, are the best attractors, and atoms with low electronegativity values are the worst electron attractors. So based on your periodic table, fluorine is the most electronegative element. Okay, and why? Because it has electronegativity value of 4.0. Okay, so here in table 11.5, this is actually a 3D representation of electronegativity. So this table show you the values of the electronegativity of each elements in periodic table. So as here, fluorine has the highest electronegativity value, and then other than that, after the fluorine followed by oxygen, nitrogen has the same electronegativity with the chlorine, and so on. Okay, alright, so based on the trends here, we have two trends. Okay, the electronegativity decreases down the group from top to the bottom, okay, and then the electronegativity generally increases from left to right across a period. Okay, so actually this electronegativity is affected by the size of elements. Okay, as you go down the group, okay, we have increasing size of elements, while from left to right we have decreasing trend of size of elements, right here. Alright, so that's all for the electronegativity. So I'll see you guys in part 2. Don't forget to like, subscribe, and also give comment to my videos. Thank you guys. So I'll see you in part 2. Bye.